Hi guys, welcome back. Today we're going to be looking at quarterly reports, and we're going to analyze the sentiment of those reports with natural language processing. And as an example, I have Apple quarterly reports. So if you check out my program here, in this program we generate sentiment scores for the sentiment of these quarterly reports. So basically we have an NLTK submodule that analyzes the sentiment of text. And the sentiment analyzer can analyze the text and develop a compound score, which is basically a score between -1 and +1, which I have here on the right axis. On the left axis here I have the closing price for the Apple stock price. And this is over 1 year. So what's interesting about this? Well, if you want to make investment decisions, you can immediately look at stock prices, but you can also look at quarterly reports. Now, quarterly reports are given by all major companies, but they're typically not quantified. And here what we've done is we've quantified these quarterly reports and the sentiment of those reports. And as an example, if you check out the actual scores here, I have them printed out here. We have 4 scores, like I mentioned. We have negative scores. None of the quarterly reports are analyzed as negative. Some are more neutral than positive. And we have a compound score here at the end. And the compound score is a combination of negative, neutral, and positive scores. Even the compound scores are pretty close. The first 2 digits after the decimal are 0.98, and we have small differences. Now, this is my first attempt at analyzing the sentiment of text. So I use kind of the base text analyzer, but you can use better sentiment analyzers, and you can even create your own. So that's an example of the possibilities here from natural language processing. We're going to go through this. So here's my program file. It's sentyt.py. So I have a small description here at the beginning. Then I have some of the sources I used for my code. There are 4 quarterly reports that we look at in this project. I have the URLs of those quarterly reports here. And then here are the packages or modules that we import. Now for many of these, you want to first install them with pip. So you want to go into the command prompt and type pip install, and for instance, pandas. We'll see that everything's already installed. But some of these are new modules. So we have datefinder, we have yfinance, that's to get our stock prices. We have matplotlib, that's to make the plot. Now, some of this will look familiar. We use some of the same packages as the previous projects. Here's a new line here. This is our SentimentIntensityAnalyzer. We're using the one with NLTK because we're familiar with NLTK at this point. Now check this out. So we have these 4 URLs. One thing that we can do with the 4 URLs is to create a list of the 4 URLs and then just loop through the list with a for loop and then grab the text and then analyze the text with our NLTK process. Right? That would be easy, but I'm kind of thinking ahead here. I'd like to grab more than 4 URLs, maybe 8 URLs for 2 years, maybe 12 or 16 for 3 and 4 years of data. So let's look at the URLs. This is just for one company. This is for Apple. And this is our first quarter results here from Apple, second quarter, third quarter, and fourth quarter. Now look at the URLs here as we flip through these tabs. The year is the same because we're just looking at 1 year of quarterly reports, but then the month changes here. So we have 05, and this is for the second quarter, 02 for the first quarter, 08 for the third, and then 10 for the fourth quarter. So we know that these numbers change with each quarterly report. Now what also changes in the URLs is the quarter. We have first quarter, second quarter results, third quarter, and fourth quarter results. Okay, so fourth, third, second, and first. That also changes with the month. So I'm creating another list of those quarters, first, second, third, and fourth. Now similar to the previous projects, I'm going to create a for loop. I'm going to identify the URL. And I'm going to format the URL based on the month and quarter lists. However, now we have 2 aspects of the URL that are changing. So we have our 2 lists here, and I have 2 empty lists for data, scores, and dates. Now I'm going to fill these lists with data. Okay, so data I'm going to fill with the text from the websites that we scrape. Scores, these are going to be the sentiment scores from the sentiment analyzer. And then dates, well, if you look at this command prompt, I've printed out the dates for the scores of the sentiment analyzer. So we're going to have to scrape the dates also from the web pages. and then put the dates into this list. And from the list, we can create a data frame and then print out all of the relevant information. Now, the for loop is going to loop through 4 quarters of reports. So quarter will be first, second, third, or fourth. We're going to loop through 4 times and grab the text from those quarterly reports. Now, if you look at the URL, this is the URL that we just looked at, but I have curly brackets in place of the month, 02, 05, 08, or 10, and we have the quarter here at the B spot, first, second, third, or fourth. So these 2 spots, A and B, in curly brackets are going to be formatted according to the lists here for quarter and month. And it's going to give us our 4 URLs. I left in this line of code with the request. This is the line of code we needed for the FOMC website. HTML, same as before. Soup, same as before. And this line for the text. We're looking at the attribute of class and page body copy. Let's look at the page source for the websites. So this is the HTML for the 4th quarter results. I'm going to scroll down here a bit. Here we go. Here it says Cupertino, California. Apple today announced financial results for its fiscal 2024 4th quarter ended, etc. And we have 1, 2, 3, 4, 5. Looks like 5 paragraphs roughly of text. Here's Cupertino, California. Apple today announced financial results for its fiscal 2024 4th quarter, etc. And 5 paragraphs of text. So this is what we want. If we look at the text here, we can see that the class is page body copy. So that's the class we want. And here we go. Class I identify as page body copy. And we can run this and I can show you some of this text. I'll use print and text all. That's what I've identified as the text here. And so let's look at some of that text. And here we go. So in this case, we can see the HTML tags. We can see all of our text here as well. Now, what's different in this program from the previous one is we use find all rather than find. So if you look at this page source, we have page body copy, page body copy, page body copy for each paragraph. This wasn't the case in the FOMC results, if you look back and you remember. So if we look back at the FOMC website, we look at the page source, we just had one tag for all of that text. We just had one class for all of that text. But in this case with Apple, we have a class identifying each paragraph. So we have to use find all rather than find. With find all, we have to loop through these elements of text all. So for element in text all, we're going to define text 0 as element.getText. I'm going to strip out the white space, and then we're going to add it to the previous text that we got as we loop through the elements in text all. So text will grow as we loop through text underscore all. We can see this in real time. Let me show you. I'll print text 0. Here we go. So we've eliminated some white space. We don't have those tags up here anymore. We still have white space between the paragraphs, but that's okay at this point. And this is for the 4th quarter results. This is for the 3rd quarter results. You can kind of see in the text, it begins with Cupertino, California. Now we can tokenize this text as well. So if you remember with natural language processing, we create a list of all of our text and we identify the words, we identify the text that we want, we eliminate the words we don't want, and so on. So I'll show you this. I'll print out the tokenized text here. And if you remember from the previous videos, this is going to look like a list. Each report is a list. You can see by the closed brackets here. So we have 4 lists that we've printed here. Now we don't have one large list here like what we had before. And this is okay because each quarterly report we're going to analyze separately and generate sentiment scores. So we go through some of the same processing as before. We have words, list words, low words, remove words. We lematize the words. I delete a couple words like Cupertino and California. In this case, we're just analyzing the sentiment of the quarterly reports. So we could have left these in here. It probably would be the same. And then at the end, we can print the result of all of the processing. Let's print this item, the unique string v2. Here, Apple today announced financial result, fiscal 2024 fourth quarter. You can see here in this first sentence of the report, we have a date. Fourth quarter end September 28th, 2024. So this date is important because this is when the quarter officially ended. It's not when the report was published. This fourth quarter report was published on October 31st, 2024, but the fiscal 2024 fourth quarter ended September 28th, 2024. So September 28th, 2024 is the date I'll associate with the sentiment score for this quarter. So this is our text. It's all cleaned. You can see it's all lowercase. We've removed stop words. And this is what we're going to analyze with the sentiment analyzer. Now at this point, I grab those dates. So I use something called a date finder. So I have date finder set up to look through unique string v2 and look for dates. Now when it looks through unique string v2, it's going to find lots of dates. It's going to find things that aren't really even dates. So we have this first one, September 28th, 2024. It's going to identify that right away as a date. It's going to be the first date that it finds. But let me print some of the results from this for loop with date finder. And I'll show you all the dates that it finds. I'm not going to print out unique string v2, and I'm not going to break after the first match. We're going to get all of the matches for dates from date finder here. And there we go. So date finder has looked through this text and it's found all of these matches for dates. And some of these don't make any sense at all. So if we look at this, September 28th, 2024 is the first date in this fourth quarter of text. And here it is. Now I also have the results from the third quarter, the second quarter, and the first quarter here, but I just want to give you an idea of all the dates that it finds. So after this first date, it finds 2024, 12/06. Let's see if we can find that in the text. Well, here's a 6, revenue billion 6%, dilute earnings per share 1, 12%. Well, here's 6, here's 1 and 12. So it seems date finder is finding the 6% or 12%, and it's identifying those as dates. So date finder is working very loosely to identify these dates. But luckily, the first date at the top of our text for each quarterly report is the date that we want for that quarterly report. So when we do our matches, I'm just going to break after the first match. For the fourth quarter, it's 9/28/2024. And if you remember that dates list that we made at the beginning, here, dates, now we're going to append it with those matches. And now the fun part of this, we're going to use the SentimentIntensityAnalyzer from NLTK. So we're going to call it SIA for Sentiment Intensity Analyzer. And we're going to print out the polarity scores here from those 4 quarters of data. And here they are. Like I said, really no negative sentiments. Looks like in this fourth quarter, there is a little bit of a negative sentiment here. I wonder where that came from. We could look back at the text and see, but there's really no negative sentiments here in the quarterly reports. Only good things to report from Apple. Neutral, we have some neutral ratings here. Positive, we have some positive ratings as well. I'll move this over here for a second to look at these scores. The negative, neutral, and positive scores will be between 0 and 1. The compound score here will be between -1 and +1. -1 is the most negative sentiment you could get. Compound score of +1 is the most positive sentiment you could get. And the compound score will be a combination of the 3 negative, neutral, and positive scores. Now you might be thinking, well, how does NLTK analyze the sentiment of text? Well, let's look at the Sentiment Intensity Analyzer. This is the page for the sentiment analysis in NLTK, and it shows some sample usage for sentiment, but basically it associates words like smart, handsome, funny with positive ratings. Good, positive sentence. And then words like bad, horrible are associated with negative sentiments, negative sentences. Now you can imagine this creates some tricky situations. So how about a phrase like Vader sentiment analysis is the shit? Now that's a positive sentiment, but it has this word here, shit, which has negative connotation. Sentiment analysis has never been good. This has a negative sentiment, but it has a word here, good, that's positive. So this is really the tricky aspect of sentiment analysis, is understanding the context of these sentences and then determining the sentiment based on the context. So for sentiment analysis, you can compile like a dictionary of words that are associated with positive sentiments and words associated with negative sentiments. And here are some examples with some sentiment scores. Vader is smart, handsome, and funny. We would expect a rather high positive sentiment here. And that's what we get. No negative sentiments here, and a small amount of neutral sentiment. In any case, let's go back here. So we have our polarity scores, our sentiment scores. I'm going to append unique string v2 to that list I created at the beginning called data. So data will have a list of the text from each quarterly report. And then scores is the other list that I created, the empty list. I'm just going to append the empty list with those polarity scores. So I'll have a list of the text, I'll have a list of the scores, and I'll have a list of the dates. The scores are what I really want because I want to compare the scores to the historical prices and see if we can find a relationship. So I create a data frame of the scores. I call it df1. PD denotes pandas. This is back up here because we imported pandas as PD, and I identified df1 as the data frame of scores. Now you remember the list of dates we made? I'm going to insert that list of dates into the data frame of scores so I can have the sentiment scores associated with the dates. Let's print that out. And there we go. So we have a data frame here with the dates, the first column, the polarity scores in the other 4 columns. So basically I inserted in column 0, which is the first column. This is column 0. This is column 1, column 2, column 3, column 4. So the first argument in insert is the location, date at 0, and then I'm going to call it date, capital D. This is a string, and that's what I want to label the first column as. Now the third argument is dates, and that's our actual data. We insert the dates into column 0, and we label it date. Okay, now this is going to set us up for a nice plot at the end. So we have a data frame 1, it's got our scores. Now let's create data frame 2 with our historical prices. So I'm going to use something called yfinance. So you want to import yfinance as yf, but first be sure to install yfinance. Now we're going to define the ticker symbol as AAPL. That's Apple's stock ticker. And then we define ticker as yf from yfinance, and then ticker, and then ticker symbol here, which we've defined as AAPL. Now we get the historical data. I'm going to call it historical data. We're going to use ticker.history in a period of 1 year. Then we make a pandas data frame with the historical data, and we could plot this. But data frame 2 has our historical price data for the Apple stock ticker. Let's look at the first 10 rows from the data frame. We want to see how the data is organized. What's the date time index? Because I want to have one plot at the end where I combine the sentiment scores and the price data. And if we have the same date time index, that's going to make things really easy. So let's check this out. Now look at this date time index. We have the year, the month, the day, and then we have this other stuff here. We have the time. Now the time, it's showing 000000. That's what it is for each of these. And look at the -5 here. You might be tempted to think that this is a range, right? From 0 to 5. But this -5 here is actually for the time zone. But in any case, we have this extra stuff. Like for the sentiment scores, we just had the date, but now we have the date and this other stuff. So combining the two into one nice plot where we have the date on the x-axis, it's not straightforward. But here you can see the open price here. So you can check yfinance to see all of the information here that's grabbed from the stock ticker. Let me show you the information for this data frame. So I'm going to print df2, which is our data frame of stock prices, with .info. We're going to just look at the information associated with it. So we have a date time index with 252 entries. So we have 252 days of stock prices, not 365. Why don't we have 365? Weekends, holidays, etc. You can see the date time index. We have the year, the month, the day, and this extra information here. But the extra information doesn't change. It's all the same. So it's going to be useful for us. Here are some other columns from yfinance. We have open price, the high price, the low price, the closing price, volume of stock traded, dividends, and stock splits. You can see the count of observations and the data type as well. Stock prices will be a float variable. We have decimals. Volume here will be an integer. It's going to be like a whole number. But the date time index is going to be kind of what we're looking at here. We're going to have to make a new date time index for data frame 1 to match data frame 2 columns in order for our plot to look good, right? So we have the 2 lines in the plot. So for data frame 1, I'm going to create another column, and I'm going to call it time. And it's just going to be this string with these numbers, this extra information at the end of our date time index for the historical prices. And then I'm going to create another column. It's called date. And it's going to be what I already have as date, but defined as a string. So date will be a string and time will be a string. 2 columns separate that we're going to combine in this next line. So we're going to create this variable called date time. And it's going to be our date time variable in this format right here. Year dash month dash day, and then hour, minute, second, and then Z, this other stuff, that's the -5. And date time, the column will be date from data frame 1 plus a little space. We can see a little space here if we look at this from the historical prices. And then we have time here, the time column, which is this extra stuff here. So we're creating a date time variable in the same format as data frame 2. Right, with the historical price data. And then I'm going to set the index for data frame 1 to be that date time column. Let's compare our data frame 1 before we changed the date and then after we changed the date. Okay, let me move this around. So this first data frame was before we made the date time variable. These are the dates that we found with datefinder. We put them into this data frame. And then date time is the variable that we just made. We've added this other stuff here, and we even still have date. This here, date time, is the date time index. Here we have date time. This is that string variable that we had before. Okay, when we combined the two. This first column is the index, and then we have our other columns that are just the variables. But let's continue here. Now we have 2 data frames with the same date time index. Let's plot them together. Now let's define the color for our plot. Color 1 is going to be steel blue. Color 2 is going to be red. Now to plot with 2 y-axes, we're going to have to use this thing called subplots. So we have PLT from matplotlib. And then we have subplots here, one of the submodules. Now for y-axis 1, we're going to define the index here for the x-axis. So we specify data frame 2, and then .index will indicate the date time index. And the first argument here will be for the x-axis variable. Second argument here is for the y-axis variable. And here I've chosen close. And the color we're going to use is color 1, which is steel blue. We're going to label the x-axis as day. We're going to label the y-axis, the first y-axis, as closing price. And then we move on to the second axis. AX2 is for our second y-axis. We're going to use this submodule called twinx. And then again for the plot, first argument will be the x variable, which is going to be our date time index. Now we're looking at data frame 1. And we just want the compound scores from data frame 1. And we're going to use color 2, which is red. Let's call it SentimentIndex, and then we're going to show the plot. And here it is. So we have the closing price on the first y-axis over here, the sentiment index on the second y-axis, and then day on the x-axis. And this is our date time index. So the red line here is our sentiment score, the compound score. The blue line is the historical price for the AAPL stock ticker. And we have a nice graph. Now you can save this. I'm going to call it sentyt.png. Now I have a PNG file or image of this graph. Now if we look at this, what's kind of interesting about this? Now this is only 1 year of analysis, But can we see a relationship? It's a little hard to see a relationship here, but we simply don't have a lot of data. We only have 4 sentiment scores. A future version of this I'd love to make will analyze more quarterly reports going back several years and for different companies besides just Apple. But for this example, we're just getting our toes wet, right? Now in this case, we use the NLTK's Sentiment Analyzer. And the Sentiment Analyzer is more made for social media analyzing, like Twitter, tweets, and things like that. So it may not be best suited for quarterly report analysis from corporations like Apple. But this is a good baseline for us to start with. We're already familiar with NLTK, so it makes sense to use the Sentiment Analyzer. But maybe we can create our own Sentiment Analyzer and then apply that Sentiment Analyzer to different corporations' quarterly reports. And the quarterly reports could present like another information set that would now be quantifiable and easily interpreted for multiple corporations over long time periods. But that's it for now. Thank you guys. If you like this, like the video, subscribe. I have a couple more projects I'm working on with natural language processing, and I think there's a lot of possibilities there. If you think so too, like and subscribe, and yeah, I'll see you guys in the next video.